Welcome, welcome, welcome. We are back here with another DevHub Live. Excited to have everyone here again. We are back with focusing on preparation for the hackathon building. This is another workshop-based DevHub Live. I'm really excited about it. Let me do a couple of housekeeping things before we bring up our special guest to talk today about chain signatures. Chain signatures are a really big piece of what's happening here on Near. It's a really cool piece of technology, and we're going to do some actual hands-on stuff today as part of the, Teach Joe workshop lesson here. If you haven't already, please check out redacted.devpost.com. That's where you can sign up for the hackathon for Redacted. Is tons of prizes. We are well over $600,000 in prizes. There are tons of tracks that you can build on. It is open to all types of developers. So whatever your specialty is, whatever your focus is, whatever your interest is, there is plenty of time to still build something in one of these different tracks. The final date is like October 25th. That gives you over a month here, about a month here, to keep building and growing from there. We really want to make sure that everyone feels comfortable with everything that you're building. And so we have tons of things and tons of opportunities to actually get involved and learn more. If you have not already seen, I'm going to pull up here. Where is some of our different stuff? I have tons of notes here. Please check out the Near docs that's scrolling here at the bottom. We'll talk more about that, and we'll point specifically to the chain signature stuff as we get going. You can also always just jump into any of our different Telegram chats. You can jump into the Near Discord. There's going to be help there for you. We want to make sure that you feel totally comfortable. You're not building on your own. Lastly, is fully online if you haven't already signed up. You do not have to attend, but there is an awesome event happening in November as well called the Redacted, which is the Redacted Conference. So all this goes together, but you don't have to do both. You can just do the online hackathon, and if you win, you still get your prize. You don't have to actually show up or anything like that. But please make sure that if nothing else, you sign up for the hackathon because you don't want to miss out on $600,000 worth of prizes at all. So today's topic is chain signatures. There's been a few different tutorials. There's been a few different things of, we've done some different videos. There was an AMA a few weeks ago, but today we're going to really focus on actually building. So I have two very special guests. I have David and I have Felipe coming up. They're going to teach me and teach you as the audience how to build with chain signatures, what it really means, how do you actually leverage it, and why it's kind of unique on Near. So before we waste any more time, let's bring up David and Felipe. Hey guys, how's it going?
Hey, it's a busy day as always. Like lots of chain signature stuff going on.
Yes, yeah. No, it's such a busy time, but this is such an exciting, I think, aspect of Near to start building on, and developers from hopefully other ecosystems can see this as an opportunity to come at least explore Near, because chain signatures really open things up. So why don't we start at the high level before we get into like super technical stuff of like what exactly chain signatures means and what actually is it on Near versus maybe other chains?
Sure. So what chain signatures is, in sort of a very simple term, is it's the ability for any near smart contract to hold private keys. Now, when you interact with any blockchain, what you do is you have a key and you go and you interact with it. And generally those are really hard to use. They're kind of messy. You can lose them. And what people have done is they built these things called account abstraction. And what we have at Near is the next level of that, which is that you can use any smart contract to control your Near account. And once you're in your Near account, you have keys that you can control. This means you can do really easy onboarding for users. So sort of social login, multi-party, multi-approvals, but also you can do things like trading keys, trading assets, and having the gas topped up in your account before you use it, making things really, really easy for your users. But you can build anything you like on it. It's a really, really powerful primitive.
Yeah. No, that's really, I think that's a great point, is that it's, you are not restricted by any means with this, right? Like there is just, if you can dream it, you can kind of build it, and you're not really even restricted on, again, it starts maybe with Near, but it doesn't have to end with Near. And I think that's an
We really,
important part.
we really see ourselves as like kind of a value add. So you have your Ethereum application, and you noticed it used to having trouble onboarding, or having trouble using your application. You add near chain signatures, and suddenly your users are using it like a Web2 application. And it's super easy to wrap your head around, because if you want to sign something with a key, all you do is you send a message to near blockchain saying, sign this thing with a key. And whether it's Bitcoin, whether it's Ethereum, whether it's Dogecoin, we can interact directly with those chains in exactly the way you'd expect it to.
Yeah, that's a great point here too. I like that part of like it's you get to interact the same way as you would. So we're not trying to enforce a new methodology of actually, you know, communicating with other chains. We're just simply trying to simplify that, unifying, right? That's probably the right word, right? Is unification of that experience for someone. And as a developer, besides the fact that I can now build on the chain, what does that really unlock for me as a developer?
Sure. So a big thing that we're looking at now, like a real sort of growth area, is AccountFi, which is the ability to buy and sell whole accounts. Now, if you have been using an account for a long time, you can you get some sort of credits. You know, you can have some tokens in there. You can have some airdrops yet that haven't landed. You can have all this kind of stuff. And you might just say, you know, I want to get some cash now. So what I see a lot of people doing is putting markets up. So on our thing, all keys are just NFTs. And anything you have in your account, whether it be Bitcoin, Ethereum, an airdrop, a soulbound token, you can simply just go out there and you can just sell your whole account. It costs 1,000% on Near. You don't need to do any Bitcoin transactions. And suddenly you have these ultra low cost markets for absolutely anything on any chain.
Yeah,
Okay, that's
no,
very
it's really exciting. Awesome. Let's dive in. So we only have about, less than an hour. So let's kind of dive into some of the technical stuff. This is geared towards developers and building. Where should we start, and how do you guys want to go about this?
I'm happy to, if we can start with a bit of Q&A, if there's anyone who has any questions about how to use this stuff. That's always the first thing. And Felipe can talk about sort of where the jumping off point is, how you start building an application.
Yeah, sure. So yeah, if you want to put questions on the chat, it's going to be easier to guide this. But to start building applications, I think we first have to understand a little bit how the contract works. So we have a smart contract deployed on Near that you can call using your Near account. And basically what you have to provide for the contract, it's the payload that you want to sign. That's a hash. And you have to provide the path of your key. And that's what determines that you have unlimited accounts in other chains. So based on the path that you provide, you're going to get the key in the other chain. And that's going to be used to sign your payload. So you're able to execute. So you get the signature back from the contract, and then you execute by yourself. So the contract just provides you the signature, and you send it to the other chain by yourself. Yeah, we can do that. That's one way to do that. And I don't know if you want to get into more details, but you also have the multi-chain contract, and multi-chain gets relayer contract. And this one, I think David can explain more, but that one I think can execute the transaction for you instead of you get the transaction back and sending to the other chain. Yeah. I don't know if it was.
No, I was saying, yeah. Let's start there, because I think that's important for people who are building and new to this. So there's actually two different approaches to how you actually go about this. Can one of you explain a little bit more about what those two different approaches are exactly?
So let me see what you're sharing here.
I'm just showing the docs, but if you want to show something, you can drive the screen too.
Okay, yeah. So I'm not sure what is. Let me think what I can share here, because you have a package that a front-end package that is easy to use and to integrate that we built at Near, and we have some examples of this one how to use. Maybe that's a good one to start. Let me get it here. Let me just open it before. So multi-chain. Okay, let me just, how do I share my screen here?
At the bottom, you
Present
should see
here,
share screen. Yeah, and then
and I
I'll
can
add you
do
to the
share
stage.
screen. So I can do a window, and we can come here. Okay, so that's a tool that we've been using here at Pagoda to integrate with our tools. So it's basically a package that allows you to easily communicate with the multi-chain contract. For the chain support that we have, here we have a Bitcoin and also EVM, so you can use any of them, and both of them works the same way. You basically submit a transaction, and we're going to prepare it, attaching everything that's necessary for you to do a transaction. So we can go for Bitcoin. You can do an example here. So basically, the method that you're going to call, it's this handle transaction method. It's going to accept the data. That's basically a Bitcoin transaction that's going to contain the UTXOs that you want to transact or the script that you're sending. The near authentication part, it's basically the key pair that you want to use to sign this, the account that you want to sign, and also the deposit you have to deposit for the contract authentication transaction. And as a path that I shared with you before, that's basically the key that you want to use for a transaction. So you can provide anything that you want here. It's just a string. You can provide anything, but we do have some recommendation pattern that you should use to make a better management of your keys. But it's basically a string. And using this key, you're going to get a key in the chain, and you can sign transactions. So when we get the transaction here, we're going to derive your address based on the public key of the contract and also the path that you're providing. And you're going to get the address on the other chain. Then we're going to prepare the transaction, the inputs and outputs of this, and you're going to sign your transaction. And what you get back of this, it's basically the transaction signed. Oh no, this one, we actually send a transaction here. So you're going to provide the RPC for us, and we're going to send a transaction for you from inside the package. And that's as simple as this to use this. And for EVM, it's going to work pretty much the same way. So if we come to the EVM example here, we have the handle transaction. And what we get here is basically an Ether-like transaction that's really looks like what you send to MetaMask when you're sending like an arbitrary transaction. We try to follow this pattern to make it easy to integrate the authentication path. And here we prepare the transaction the same way. So we get an address, and then we get the nonce and the guess, and then we serialize it and hash it, and then we send it for the contract for signature. And then we build a signature back, and we send the transaction for the contract, for the other chain, I'm sorry. And these are the two that we support now. It's available in this multi-chain tools package. I can post the link here on the chat, I think. So maybe it's easier for comments. Oh, join the chat. I have to
go to
YouTube.
To private chat. Yeah. And I'll share it.
Okay. Then I can post. Okay, cool.
Yeah, there you go.
Okay.
Perfect.
And then if you want to see some places that we are using this, we also have two other repos. One of them, it's the multi-chain demo. And this one is just a very basic app, but let me get another one here because I have my sandbox here. Sandbox, yeah, this one. So this one, I can show this one running, I think. I think it's a good idea, no? If there's no question in the chat and I can keep going, I can show how this actually works.
Yeah. Keep going. I'll interrupt you. Yeah, no problem. You're doing great.
Just let me know if I'm talking too much, and then
no.
I can stop. So let me just get this stuff running here quickly, and I can share my screen again because I'm using ultra wide, so I have to keep changing where I'm sharing stuff.
Well, while I was pulling that up, David, you want to talk a little bit about the security behind this? So I think it's a little different than people maybe expect, where there is no actual private key that I'm interacting with, that I'm holding or anyone else is holding, right? Can you talk a little bit about that?
Yeah, sure. So it's a bit of like kind of mathematical magic, this. So kind of normally what happens when you have a key is one person generates a key. And if you use something like, there's a lot of networks out there which can allow you to share keys, so split keys up using something called finger sharing. We don't do that. What we do is we use this thing called multi-party computation. And what multi-party computation is it's a way for a bunch of different parties to work together and run a computation in such a way that none of the parties can see what's going on inside the computation. So we have a network of nodes, all of them run by sort of different, like well-respected operators, which you can see a list of on our website. And what they do is they all kind of meet up. and they get together. They generate a secret key that none of them will ever see. They then deal shares out in such a way that none of them can see the dealing process. And then once they have those shares, they can go and they can start signing. Now, the signing only works if a threshold number, so all of them bar 2, get together. And it's super secure. And when the node operator change, what they do is they go back into that process of generating a key, but they regenerate the same key again. And that means if you have a threshold number of nodes, you can change the sets of operators inside there. And that means that you don't sort of lose your keys when people come and go. But again, no one ever sees a key. And that means that you can be sure that your smart contract is the only thing that has ever had the ability to sign things using that key. And actually, everyone's using the same key in a very weird way because we use something called key derivation, which can be done homomorphically using this protocol. So yeah, really cool cryptography. It kind of seems like magic when you start building on it and it starts working and you read all the papers and it's somehow secure, which is very, very cool.
So really interesting. Where the key part of this here is is it possible to exploit that though? Like, are there ways that people are able to actually be still in the middle of that?
So all code can have bugs, and that's it is. So one of the things is it's theoretically not possible to steal the key without having a threshold number of signers agree to sign something with it. In practice, it is possible code to have bugs, but we've audited it, we've reviewed it, we've done a mathematical review on sort of the properties of the model we're using by a really top-notch academic. So never say never, but we're pretty confident in this.
No, yeah, awesome. I and one of the things I think when we talk to developers at DevHub is that it's really around just changing a little bit of the mental model that you're maybe used to if you already were building on blockchain, where everything was so heavy of like public key, private key, or everything I'm building, and it's so worried about my seed phrase and my, and protecting that, where this is really pulling that away. And Near with the account abstraction that we have here, how does that all then play into what's happening as well? Or is it just kind of like a nice add-on to what's already there with the MPC?
So the push to account abstraction is amazing. It's really sort of, in my opinion, it's making it so real people can use crypto applications. Because for years it was really, your mum didn't want to come on and see, you've got to learn this 20 words and they have to be secret. You have to store them somewhere, but don't let anyone see it. And that's kind of like, that's your introduction. It was always terrible. People always lost their keys. Every single wallet, their main thing was people saying, I've lost my key, can you fix it? Hundreds and hundreds of people losing sort of very, very real assets. One of the problems with regular account abstraction is that it's per chain. So you sort of deploy to your EVM, you deploy to Ethereum, your abstracted account, and then you go over to Base, and your account is gone. And there's no way for you to use your abstract account on Coinbase to move assets on Base, which means you either need to set it up again, you need to reconfigure it. And then if you go to, let's say, I'm going to say Dogecoin, but it could be Solana or Ton or anything like that. And you want to do it, you're going to have to come up with a completely different way of doing it because they have a completely different programming model. What we do, and if you're doing it on Ethereum, it can be quite expensive, and there's all sorts of issues associated with this. Then you have security issues as well, because potentially one of your accounts could be compromised because they're all programmed in different ways. What we do is we just gut all the complexity out of that. Now, for a very, very long time, Near has had abstract accounts, and that is why we've had such success in onboarding users. I think we're sort of the blockchain with the most users of any chain, although not necessarily the highest value users, because Ethereum has a lot more TVL. But what we're doing is we're taking that sort of very, very mature account abstraction technology, and when you put a key inside it, suddenly it's cross-chain account abstraction, and that's the next level. That's you have one account, and it works on every single blockchain. And we think that offers very significant advantage in terms of cost, maturity, and finally just sort of ease of use. We have these relayers, we have these cross-chain relayers, and we have cross-chain paymasters. So it means you have all your assets in one place, all of it in one wallet, and it just makes life super easy for your users. And therefore you have better retention and people actually use your application.
Yeah, I think the piece that I always try to get across as I'm talking to developers coming in here is that, your focus starts to become on your own product that you're building and not having to worry about the technology so much. Where like we're not having to get caught up on like having to do stuff for near, right? And that's the part where too that again we've seen this now the past few years. If you've been in crypto for a little while now, you see that people are building towards a particular ecosystem. Now you can actually build towards a product and focus on that because I can leverage the strength maybe ETH does something better, so I want to leverage that, right? And so I can start doing these different things, for the, the lack of a better term, but like the maximalism that goes on of these different chains starts to evaporate, and it becomes more about, can I build a better product? Because I can even build DeFi with this as well. I'm not restricted by any means by just having like a consumer based, app. This could actually be a full-fledged financial application across multiple chains, right?
That's exactly right. And it's, from my perspective, my passion in blockchain is not for big DeFi use cases. What it is it's trying to get like 1 billion users to use a blockchain. And frankly, you're not going to convince 1 billion users of the merit of blockchain X. It's like super niche. I mean, why is optimism better than base? I don't want to explain that 1 billion times.
Right. Right.
We want to live in a world where people deploy applications to where those applications make sense. So where it's cheap or well connected or X, Y, Z. And then people have their accounts where they want to have their accounts. And basically the user has no idea what's going on. And that's what this technology is in aid of. We started off by saying, how can we make it so users have all the chain stuff abstracted away from them? So chain abstraction, how to make it so they don't need to give a shit about where they are, what assets they have. So easy swapping, easy onboarding, and then easy moving between applications. So it's not that you onboard to an Optimism app and then you can't onboard onto a Solana app. It's that you just go from app to app to app. You keep your identity, you keep your keys, you keep your assets, and you can just move them around. So that's really the beauty of this thing. That's what we aim for, and I think we've done a relatively good job.
Yeah, no, that's awesome. Yeah, I mean it's the old thing of like, I feel like there's so much trying to compare Web 3 to Web 2, yet like you said, I don't want to explain how all this different technology works and the difference between these chains. Like I don't go and like explain how my LAMP server works for my, WordPress blog, right? Like nobody cares about that. They just want to know like, okay, here's the site, here's the content. So now that we can focus more on product and users being able to have a great experience and not worry about being in crypto, I think is just a huge advantage here. Felipe, I want to just check in with you.
Yep, sure.
Ready to show something?
Yeah, I got it working here. Let
Perfect.
me just quickly show it here. It's a very simple demo, just to show the front-end integration here. Yeah, so that's what I was talking about. So here we can select the chain that you want to use. So that whenever you support EVM and BTC from the package that I shared with you. And then you can choose a path here. Like we have standards, but this one is just like a string input. So you can put anything here. And here on the side, you're going to get your key. That's basically, so you can control unlimited keys from a single near account. You can put S, it's one key. If you put S again, another key. And you can keep changing. And you're going to get like multiple keys. That's cool stuff. So I'm going to use one that I already have funds here. And I can check the balance for it. It's going to query the other chain, basically scoring Ethereum. And then I can just take my address from my wallet here. It's locked. So I'm just going to take from my saved address here. And I can put any amount. And if I click to send a transaction, let me just put a little bit less. Yeah. And it's going to call the smart contract here. And we can follow up here on the transactions. So let's just wait this, because then we can check the response. Basically, what we're going to get here is a signature on our SMV, the primitives, and we're going to rebuild the transaction in the front end. So here we get the signature back and the transaction submitted on Sepolia. So if you come to Sepolia and we check it here, and the transaction is here being executed, transferring the fund that we set there. And that's, this front end code I can share on the chat too, so the people can check and how to integrate. And BTC, BNB, and Ethereum working, and I'm working some improvements for BTC to make it faster and cheaper. That's the demo here.
It's so simple that I think sometimes people don't really realized, I think, what's actually happening here, right? There is no bridging. It is all actually, the transaction itself is actually happening on Ethereum. You just showed the Explorer where here's the transaction. Yet everything is being derived on through my Near account through the MPC, correct?
Exactly. And the way we link your accounts to your specific address, it's yeah. So we have the NFT contract. That's another story. That's we're talking before. But when you use a single account, we put on the path of your account ID. So we make sure that your account ID only controls the accounts that have your account ID on the path for it. And then we derive the address, and then we sign it, and then you get the signature back. So it's up to you to when you're going to send it or to which RPC you're going to use. We don't restrict this. We just give it a signature back, and you can forward to anywhere.
So, as a developer, I'm building a consumer app, and I have my users log in. They have a Near account now, right? So in the background, and I want them to now do something on Ethereum. Are they still signing a transaction, or am I, as the application builder, putting something together kind of like a meta transaction that's doing it for them, like on behalf of them? How does that work?
So we have two transactions, right? One on Near and in the other chain. So you want to ask if both of them are paid by the developer or just the Near one, or how it can work.
So let's use the example of like the developers paying for it. I don't want my users to have to worry about spending crypto, let's say, right? So I'm going to fund their accounts. What does that look like from a user experience? Who's actually signing a transaction?
Cool. So when we have this scenario, it's really cool because we have a tool called FastAlpha, and on FastAlpha we do it exactly what you asked. So every transaction that we send by the FastAlpha, it's going to be relayed. And FastAlpha, it's integrated with this package that I shared with you. I just demo. So basically, the FastAlpha follows the I forgot the name. It's a wallet selector standards. So you can use the wallet selector from here to call FastAlpha. It follows the standards, and you can call to sign a multi-chain transaction. And the cool part of this, it's because we support the multi-chain stuff. So every EVM transaction that you send, we're going to be able to parse it and display the information and tell the user what he's doing. So if he's like transferring an NFT, if he transfer ERC token, and when he sees the interface, he can confirm the transaction, and we're going to relay to the MPC to the chain signatures contract, and then you're going to sign there. So the user doesn't have to pay anything. But one thing that has to happen, and we don't have support to it yet, is the second transaction that happens on the foreign chain. So if you're sending an EVM transaction or BTC transaction, we don't have relayers there to pay the gas for the user. So I think if the DApp have infrastructure there, he's going to be able to pay, but we don't provide it yet. Yeah, I think that's your question, right? If not, let me know.
No, I think that's all part of it. This is kind of what I want to explore for people and developers, so we can go back and like point them to these clips here of saying, what does that actual experience have to look like? And so I think that's a great point that you brought up. So on some of these parts, right, on the other chain, there's no relayer yet. So I need to fund it. So what does that look like if I need to fund, let's say, on the other side as the developer today? Like, what does it look like today, and then what will it look like possibly in the future?
Okay, so yeah, I need help from David now. But for now, we don't have infrastructure. Like from Near, by what I know, we don't have infrastructure there. But it's possible for you to fund, because if you have abstract accounts in other chains, you can add paymasters and so on EVM, and you are able to pay for the transaction. But from our side, we don't have infrastructure on this yet. The way I see how we can do, it's abstract accounts there. But yeah, I think David can help more.
So let me just, do you want to, if I rephrase the question quickly, are you saying, do we have like paymaster support that works cross chain, or whether we can interact with existing cross chain paymasters?
Yeah, I want to clarify for developers, I guess, the concept of a paymaster and what has to happen today on the other side right now.
Sure. So the concept of a paymaster is basically in Web3, what traditionally happens is your users have to pay the cost of their action. And what traditionally happens in Web2, like obviously you have costs in Web2, but what you tend to do is you tend to get someone in for free, let them see your landing page for free, for example, and let them use an application for a certain period of time, and then get them to pay later on effectively, you can divorce your revenue model from your server costs. And that's what Paymasters are trying to do in Web3. What we're trying to do is say, like, okay, we don't want people to pay for every action they take. So we're going to sometimes subsidize them, and maybe because we expect to make more money off them later on. So that's what a Paymaster is. And what it does is it allows you to pay for someone else, whilst also they sort of preserve the ownership of the asset. Now, what a cross-chain Paymaster is the ability for you to have an account on Near, and for us to do exactly that same subsidy, but on Ethereum or Optimism or just lots of different chains. The advantage of doing it on Near, again, is the cross-chain stuff, but also you get a degree of civil resistance from our various signing methods. So, for example, if you use Google account, we have a sense that you are probably a real person. And as a result, application developers may be more comfortable subsidizing things. Now, the good thing about our cross-chain Paymasters is that you can just give someone the funds to do this without worrying about them stealing the funds. So we have the ability to control people's keys using smart contracts. And that means you can say, hey, look, I'm giving you one Optimism to use on my application, but all you can use it for is my application and these specific things. You encode that logic on Near, you give them the funds, and then you just kind of keep going. And we try and make that as easy as possible. And what this avoids is what are called faucet attacks, where people get given small amounts of crypto and then just steal it. And I'll tell anyone who's ever written a crypto app will know faucet attacks. If you have any excuse for a faucet, it will get exploited immediately, and you will lose all your credit.
Yep, absolutely. And again, trying to keep it in the developer's perspective. So if I'm more of a Web2 developer and I'm coming here, what does this look like? And I'm putting you a little bit on the spot here, but like, what does it look like from just a infrastructure type of setup? I still need to have at least a server for my front end, right? I need to host that somewhere, right? But like, what else starts to happen here? Like, what else do I need to have in place that to actually get up and running, if anything?
So right now, and we're hoping to make this not the case in the future, right now, if you want to have your users not pay Near, you need something called a relay. We have those GitHub repositories, you set it up, and what that allows you to do is subsidize certain types of Near transaction. And we also have something called Fastauth, which you can use to have user accounts and social sign-in. And what that allows you to do is sort of have a pretty out-the-box wallet experience. So you need to decide which embedded wallet your user can use, or regular wallet. And then after that, it's just a front end, more or less. And you deploy a front end, use something like Vercel or whatever you feel like using. And then you're off to the races, and you can start communicating with all these smart contracts and all that kind of stuff.
Awesome. Yeah, no, it really is that easy. I mean, that's exciting. Great stuff. David, I know you have to run soon, so thank you so much for your time and your answers here. This was super helpful. Felipe, if you don't mind staying on for a few more minutes, I want to just ask you a few more questions and see if we have anything else. But David, thank you so much. Where's the best place for people to go to get started?
Near Docs is a fabulous page. Go there, reach out to DevHub. They're really good. I mean, Joe, you're part of DevHub, so you are very good at that kind of stuff. And yeah, jump on the Telegram channels. We have a Chain Abstraction Telegram channel. And good luck. It's a really exciting technology.
All right. Thank you so much. Take care. Bye. Felipe, let's stay one more minute. So that example that you gave, that is an example where the signing part of it, the signature piece of it, is happening on the front end, or is that happening somewhere in the MPC? Can you just kind of break that down a little bit further for people, like where the signatures are actually happening?
Sure. So the way it works, you need a Near transaction, because the way the MPC works, it's basically by watching a smart contract on Near. So you're going to take your transaction that's going to contain the transaction hash of the foreigner chain. So you're going to submit this transaction hash to the MPC contract on Near, the chain smart contract on Near, and the MPC is going to watch the signature, and then with the magic that happens inside it, we're going to produce a signature and answer it back for the contract. And then we read from the contract the signature, the primitives. So it's RSMV, for a little bit more technical. And then using these primitives, you can rebuild the signature for the chain that you're using. So it can be EVM or Bitcoin, because depending on them, you're going to rebuild it in different ways. So the signature, it's built on chain, and we support ECDSA for now. Yep.
So yeah, let me pull this up real quick, and just so people can also see that. So this is basically the flow that you're talking about, right?
Yes, exactly. So the user asks the signature for the smart contract, step one, and then the step two, the MPC is going to watch. MPC is going to watch the smart contract and produce the signature, answer back to the contract, and then we, as a client on the front end, we're going to watch this contract and get the signature back when it's ready. May take some time, a few seconds, and then you get it back, and you can build your full transaction and submit to the RPC that you want in the foreigner chain.
In this setup for the developer, so I have my users create an account. So if they use FastAuth, it sounds like that I can leverage some stuff in the background. I don't have to actually explicitly have them sign a transaction. If they're using a standard wallet, they'll have to actually sign at least one transaction, right? To at least start the ball rolling. Or can I do that with a relayer still and not have them have to do that?
So in both scenarios, you always need to sign a transaction for security purpose. Because on Near, I don't know if everybody here is aware, we have two types of keys. We have full access keys, and we also have function call keys. Function call keys are allowed to call specific methods on a smart contract. So if you give this key, and this key controls a key in other chain with funds, imagine if you give a function call key to a DApp, and the foreigner key that this key controls have a 1 BTC. This DApp can do whatever he wants on the other chain. So we limit the request for signature for function call keys. Full access keys. So you can only ask for a signature with a full access key, and for that we limit with a deposit. So you always need a signature. Doesn't matter. So what difference from FastAuth for other wallets? It's that when you sign a transaction using FastAuth, we're always going to use a relayer. So we're going to sign the transaction using FastAuth. Basically, it's a signed delegate. Then we send this to the relayer, and the relayer sends to the chain. But when you use another wallet, you're basically just going to sign a full transaction and send to the chain without the relayer, without paying the funds for your transaction. That's a difference. But the flow to integrate should be the same. As far as I know, FastAuth is the only wallet that supports multi-chain signatures on Near for now, by what I know. Not sure. But it follows the Wallet Connect, wallet selector standards, and the methods are available there. And we should be expanding this in the future too. Yeah.
Awesome. This was super helpful. I think that people really get a good sense of really how to get started and get into it. If I'm gonna put you a little bit on the spot here, if you were hacking at this hackathon, what are some things that come to mind? High level, I don't need specific ideas, but like high level, what are some things people want to maybe start exploring, trying to build with this, stuff like that?
Yeah, actually, I'm making a list here too. What would be cool to build? I think one thing I would like to see, it's a wallet that shows your balance in other chains. So you have your Near wallet, but you can see your balance in Ethereum, on Bitcoin, in a single wallet. Like, I think that's really cool, instead of like having multiple wallets to doing like multiple chains. Another one, I think would be really cool to see like you being able to submit a transaction using MetaMask or other wallets, but on Near, and then you have an EVM account, controlling a Solana account or a Near account from there. I think that's a cool idea, maybe. I don't know.
Yep. Yeah.
Let me see.
I like
it. And for this function call key, I was also thinking if it was possible or no, because you could limit, like you could create a function call key and a corresponding key on another chain. But this key should be like a kind of a function call in the other chain too. So you allow the DApp to call the other chain without having to ask for signature. I don't know. I was just thinking if it was possible or not, but I think that would be cool, because then the DApp on Near can use your account on Ethereum, without asking signatures, as long as the key in the other chain is pre-configured to be like a function call key to only allow to call certain stuff too.
Nice. Yeah, I like it. And again, we keep asking people for different ideas for the hackathon as they come on the show. And I love just like everything is these seeds of ideas. And when you start to hear them all together, it just shows like the power. Like if you really want to explore and try to build with this technology, there's so much still available to build. Like there's just like we are very early in trying to just understand how to really leverage a lot of this. So exciting stuff.
Yeah.
Yeah. Any last things that you want to share or people should be aware of? We have the link down below for the docs to get started. Anything else?
No, I think, yeah, just tell them to maybe join the group on Telegram that we're all the builders are there together. Check the GitHub because all of our repositories are all open source, so you can have access to all our examples, integrations, packages, and everything. It's everything under Near. And yeah, always open to help too on the group.
Yeah. No, awesome. Awesome stuff. Again, really appreciate your and David's time today. This was super helpful. I hope people learned something, and people will have people reach out to you guys if they have questions. Thank you so much today.
Cool. Thank you.
Thanks. All right, that was really great. There's been a few different AMAs and other things so far, and this was really great to kind of talk through what actually can be built, how this actually comes together. I'm going to share a few of the things that was just brought up. Let me edit this real quick. So there's 2 spots to come in, and here, I'll put this at the bottom. All right. So there's 2 Telegram groups that I encourage everyone to join. First is /neardev. That is our main one. Everything Near related for developers, come there. Not only are the DevRels from Near DevHub there, but we also have engineers from the different entities around the Near ecosystem. We have the community members. Everyone's there to kind of help out. Great place to ask questions. Then, as Felipe and both David mentioned, we have the chain abstraction group. That's down below as well. That's /chain_abstraction. I would join that Telegram group as well. That one is much more focused on how to actually leverage chain signatures and build like that. All the engineers who are working on this infrastructure are in there as well. So if you have very specific questions, if you want to get technical, if you want to better understand something, that's a great place for that as well. So I really encourage you to join those 2 groups. Let's talk a little bit more about the hackathon. And just so that everyone here again is on the same page. So if you have not signed up, here it is, redacted.devpost.com. I'm actually going to share my screen here a little bit. So a couple different things that I want to highlight here. Right now, we are at almost $700,000 in prizes. Tons of prizes. We're almost at 1,000 participants. You have 29 days to the deadline. So that's October 25th. All right. And that's, again, there's plenty of time to try, to build, to do different things. You can work in a team. You can work individually, however you want. On the homepage, if you scroll down, here are all the different tracks. And you'll see there are some tracks that are just kind of generic where we're looking for people to just build and explore and try different things. But there's a best of chain abstraction, so the stuff that we just talked about. There's even some ideas directly right in here related to chain abstraction. So definitely check that out. There's DeFi. There's other bounties that we've talked to already, like we talked to BitDay, we talked Calamero. And you can stack these. So you can combine different pieces of this stuff to leverage all of them and actually try to win maybe multiple prizes if your product is good. And we really hope that with this extra time that you're really trying to explore. If you've never used DevPost before, this is if you're new to this, you can see the different participants here. If you're trying to find teammates, you can jump over to here. You can see obviously the rules. As boring as maybe that maybe is, everything is here. If you have questions, though, definitely give that a search. Make sure you're clear on the regulations and everything else. The important part that I want everyone to be aware of is the updates. So there are regular updates going out. Let's see, the last one was 18 hours ago, breaking down just some different things of like what's been added. Here's some different stuff. Like here's the event you're watching now. Here's some other different parts just to make sure you're being on top of, and then all the different resources here. So if you go to resources, everything I just talked about, here's the stuff with chain signatures, all our documentation, links to the different groups. You can jump right in. Excuse me. So again, there's a lot of really exciting stuff here. I really hope that everyone takes the time to come in and check this out. Let me end with this here. And if you're watching this on replay, please come ask questions. But there's so much here. And, David and Felipe just kind of scratched the surface of really what's possible. This is kind of in those early stages. This is ripe for people to take it another step further and really try to see what they can have and build from this and set their own path. So try different things. Don't feel like you have to get stuck in what you see in the documentation. Try to push the limit. Number one, that's a great tip for any kind of hackathon, is try to take it 2 steps further. That's a great way to really make yourself seen. 2, come and ask questions. This is really different for a lot of people, and for I would say most people. And again, as I kind of mentioned throughout this stream here, is like some of this stuff is a little bit different of a paradigm. Even if you've been working in blockchain for a while now, the concepts are a little bit different than maybe you're used to. So come ask questions. There's no bad questions. There really isn't. Maybe it's already been answered before. Maybe it's something new, but come join us. We want to come, talk to you and get a sense of all of that. Otherwise, until next week, we will have more of this leading all the way through till the end of October. We'll have more workshops, more things like this. Please always ask questions. Make sure that if you have a topic that you want to see, if there's something you want to learn more about, that we could spend maybe some more time on, please come and go to one of those different chats, ask the question, say, hey, I'd love to see a workshop on whatever, and we'll see if we can get it done. But until then, if you haven't already, if you want to stay up to date on everything that's happening in the Near developer ecosystem, sign up for the Near DevHub newsletter. We send this out weekly. All the things that are happening in the developer ecosystem, updates to the tooling, updates to the SDKs, changes that you should be aware of, new documentation, new examples, highlighting projects that are working on stuff, integration partners, whatever it might be. Come sign up for that, get that newsletter. It's an exciting time. You'll see tons of great stuff that's always happening. It's really, really super active. Again, I am your host, Joe. We're here every Thursday at the same time, and I encourage you to keep coming, keep building. And if you have any else that you need, please come reach out to us, because we want to see builders building really cool stuff, and that's what our job is here. So signing off for now. Until next week, enjoy. Take care.